Study Guide 18, number 11. Again, we've got the Pythagorean theorem. This time we know A, and we know B, and we don't know C, which is the hypotenuse. So, leg squared plus leg squared equals hypotenuse squared. 16 plus 64 is C squared. And 16 plus 64 is 80. Let's take square root of both sides. Two answers, but we only need the positive. So I've got C is equal to the square root of 80. Let's do the factor tree of it. 2 goes 40 times, 2 goes 20 times. I'm just going to keep doing my 2's, 10. And then 2 goes 5 times. So I've got a pair of 2's and a pair of 2's. So I've got the square root of 2 squared times 2 squared times 5. Well, we can take the square root of these 4's out. So square root of this 4 is 2. Square root of this 4 is 2. Square root of 5 is irrational. So when we clean that up, we get 4 square root of 5. Number 12, we're going to distribute just like we did in number 10. It's already written out for us. Let's take the 4a and distribute it across. So I have 4a times 2a is 8a squared. And then plus 4a times c will be 4ac. And then come back and distribute the negative 2c. So negative 2c times 2a is negative 4, and I'm going to write it in alphabetical order, ac. And then the minus 2c times the positive c is negative 2c squared. Well, positive 4ac and negative 4ac are going to add out, and we end up with 8a squared minus 2c squared. Number 13, you got a factor. There is no GCF, nothing they have alike, so let's go ahead. I'm going to put my binomials here, but I'm going to go ahead and do my x, which will have a 30x squared on top and a positive 13x on the bottom. Now we need factors of 30 that will give me 13. So you've got 1 times 30, 2 times 15, and everything's positive, so they're going to be positive. You have to be careful because, see, these will give you 13, but with subtraction. And then 3 times 10, I believe that's the one we need because 3 plus 10 will give me 13. So in my box, I have 6x squared and positive 5. And then I'll replace the 13x with the 3x and 10x. The GCF across the top is 3x. If you take 3x away from this factor tree, you'll have a 2x left. And 3x away from this factor tree will just leave you a positive 1. If you take 2x away from 10x, you have a 5 left. That's a positive 5. And 5 times 1 is 5. So our two binomials are, and it looks a little confusing there, but I think I can do it, 2x plus 1 and 3x plus 5. Number 14, let's solve and we'll graph this one. Now, you can move either variable. I like to move, even though it's going to make it negative, I'm still going to move the 4x. I like my x on the left, especially with an inequality. So I have negative 1x minus 5 is less than or equal to negative 8. Subtracting will never change the inequality. Now let's add 5. And we get negative 1x is less than or equal to negative 3. Adding never affects it. But when we divide by the negative 1, we'll get x is greater than or equal to positive 3. I'm going to do 1, 2, 3, 4. Well, when you put 3 in, 3 is equal to 3, so 3 is true. And then numbers bigger than 3 are going to be to the right. Oh, sorry. There you go. Okay, this is like the first one we did, but you're adding all square root of 11s, so you just need to put your like terms together. You've got 6 minus 5 plus 3 minus 1. So 6 minus 5 will give me 1 square root of 11, plus 3 square root of 11 will give me 4 of them, and then 4 minus 1 will give me 3 square root of 11. Okay, got another multiplication problem. we don't have any trinomials, so we're just going to have GCF. So I think I'm going to come over here and just rewrite them. 12x cubed minus 6x has a GCF of 6x. That leaves me a 2x squared minus 1. I think that probably was supposed to have been a 12x squared, but we'll go ahead and work it like it is. I don't know. We'll see what's going to happen down here. Over the bottom, we're going to have 10x squared. And we'll have x plus 2. And let's see, 10x cubed, that's right, plus 20x. Now the top, we're going to take out a 5x. And we'll have x plus 2. And then this one has a GCF of 4, which will leave me 2x minus 1. So I believe that was supposed to have been a squared. I probably just typed it wrong when I typed the problem, but we could still work it like it is. X plus 2's are gone. Now I'm going to do something a little odd, but I've got x and x squared on the bottom. So I'm going to go ahead and mark out the 2 x's on top and 2 on the bottom. Now you can cancel the 6 and 10 or the 6 and 4. I think I'm going to do the 6 and 10. 2 goes 3 times and 2 goes 5 times. Oh, and then my 5's will cancel here. Now it's a little messy, but it looks like I'm left a 3 on top and the 2x squared minus 1. And on the bottom I'm left a 4 and a 2x minus 1. Number 17, what is the percent of increase from 20 to 24? If you remember, percent increase or decrease is the change over the original. Well, the change from 20 to 24 is 4, and the original one is the 20, and I'm just going to go ahead and reduce that to 1/5. Now, if you want that as a percent, you can multiply by 20 over 20, go back, or you can divide 5 into 1. Most of you probably know that is 20% by just looking at it. Number 18, subtract and write in standard form. Okay, to subtract a polynomial, you need to go ahead and distribute your -1, because that's what that is right there. So I'm going to go ahead and write it 4x minus 2x squared plus 9, and then minus 12, and then minus 6x squared, and then plus 5x. I'm just distributing that -1 all the way across. Now, because it said standard form, we need to start with the x squareds. So I have -2x squared. That's our highest exponent. So we've got -8x squared. I'm going to mark those out. Then I'll do my x's. I've got 4x plus 5x, which is 9x. And then I've got my constants, 9 minus 12, which will give me a -3. Number 19, solve for x. Haven't done the fractions with equations with fractions in a while. Let's get a common denominator. And the common denominator of 3, 1, 4, and 2 will be 12. So let's multiply this one times 4 over 4. And this one times 12 over 12. 3 over 3. And 6 over 6. So I now have, and I think I'm going to move over here. I now have 8x over 12 minus 24 over 12. I have to be careful with my variables here. Equals 3x over 12 plus 6 over 12. Now, because my denominators are the same, my numerators will be equal. So I have, I'll tell you what, let's move over here. We've got 8x minus 24 is equal to 3x plus 6. Okay, I'm going to move the x's. I'm going to move my 3x. And I get 5x minus 24 equals 6. Add 24. Oh, got one that's going to come out even. 5x equals 30. Divide by 5, x equals 6. Number 20, write in slope y-intercept form, state the slope and y-intercept. So we need to get it in y equals mx plus b form. Remember, m's your slope and b's your y-intercept. So let's subtract the 3x. And we get negative 2y is equal to, and I'm going to go ahead and commute that and write it negative 3x plus 12. And then I need to get the y by itself, so let's divide everything by negative 2. And we get y is equal to, now this will reduce to 3/2 x, and then this will reduce to negative 6. So my slope is the number in front of the x coefficient, which is 3/2, and my y-intercept is negative 6.